Hello students, today's topic is very important topic for the point of view of JEE Mains, JEE Advanced as well as for Neet and CBSE board also. So our today's topic is reduction in organic chemistry or reduction of organic compound. Before discussing the importance of this topic, let's solve these two questions first of all. This is a reactant, and in first reaction we are reacting this reactant with lithium aluminum hydride in ether. So we are forming the compound A, and we have to find out what is the structure of A. Let's see. So we all know that lithium aluminum hydride is a very strong reducing agent. It reduces carbonyl group as well as it also reduces ester. So it reduces carbonyl group means ketone group into 2-degree alcohol and ester into alcohol. So our product will be like that. CH2OH plus CH3OH. So when we are reacting this reactant with lithium aluminum hydride, then it will convert this ketone group, keto group into 2-degree alcohol, as well as it break this bond of ester and convert it also into alcoholic group. But in second reaction, we are reacting this reactant with NaBH4, sodium borohydride. As we know, sodium borohydride is not a strong reducing agent. It's somewhat mild reducing agent, even we can say milder than lithium aluminum hydride. NaBH4 does not work on esters, so it does not reduce esters. Sodium borohydride reduce only ketone group into 2-degree alcohol, so it will not affect the ester group. So our product will be like that. So that is our B product. That was our A product. Let's solve another question. Second question. There is another reactant, and in first reaction we are reducing it with the help of hydrogen at nickel. So what is the structure of X? We know these catalyst hydrogenation means like when we are using H2 in the presence of Ni, Pt, Pd, then they reduce that double bond, as well as they also reduce this amide group into amine group. So our product X will be like that: CS3, CH2, 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 and CH2NH2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Number of carbon will be same. So we can say when we are reacting this compound with hydrogen nickel, then this double bond also reduce into single bond, as well as this amide will reduce into amine. So X will be like that. But when we are treating with lithium aluminum hydride, LAH means lithium aluminum hydride. So what will be the product of Y? So we know that lithium aluminum hydride does not reduce that double bond. It reduces double bond only in one condition, when this double bond will be in conjugation with phenyl ring. So this double bond is not in the conjugation with phenyl ring. So we can say LAH, lithium aluminum hydride, will reduce only this amide group into amine and does not affect this double bond. So our product Y will be like that: CS3, CH2, 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 NH2. 1, 2, 3, 4, 5. Number of carbon will be same. So, sorry, double bond. It will not affect the double bond. So, double bond will remain intact in Y. Next is NaBH4, sodium borohydride. We know that sodium borohydride does not affect amide as well as does not affect the ester. Sodium borohydride also does not affect the double bond. So our product will be as like reactant. It will not affect any of the functional groups, CH3, CH, double bond CH, CH2, CO, NH2. So our product will be same as a reactant. When we want to reduce it with NaBH4, it will not reduce it. So how we can solve this question, or how we know these answers? If we know that which functional group is reduced by which reducing agent. We know some reducing agents are selective in nature. They selectively reduce particular functional group. But some reducing agent have a broad coverage. They reduce a lot of functional group. So let's see which functional group is reduced by which reducing agent, or we can say how many type of reducing agent are present in organic chemistry. Obviously, we can't cover all reducing agents. That's why we'll discuss some important reducing agents as well as how they reduce the functional groups. So let's see our topic. So first of all, we have to know how many reducing agent we have. We have a lot of reducing agents. Among these lot of reducing agents in organic chemistry, we are discussing some important reducing agents. For example, first one is that LAH, lithium aluminium hydride. Second one is NaBH4, sodium borohydride. LAH we should take in ether or non-hydroxy solvent, NaBH4. Then third one we can say H2 in the presence of Ni, Pt or Pd, palladium, etc. And fourth reducing agent we can say metal plus acid, like zinc plus HCl, Sn plus HCl, zinc plus H2SO4, or we can say Fe plus HCl. So metal plus acid. And fifth category, that one is alkali metal plus alcohol. So for example, sodium in ethanol. 5 reducing agent, important reducing agent. Then sixth one, there is another, that is red phosphorus plus Hi. Red phosphorus plus Hi. We are not discussing here some selective reduction that are also important, but we have previously discussed these reduction, that selective reduction like Clemenson reduction, Wolff-Kishner reduction, we have already discussed in our other video lectures. So in today's class, we will discuss these all reducing agents, as well as we will discuss the effect of these reducing agents on different functional groups. So let's start. Lithium aluminium hydride in ether, it is a hydride donor. Hydride means H minus ion donor. So it is a very strong reducing agent. Lithium aluminium hydride, a very strong reducing agent. It reduces almost all functional group, but it have some limitation that it does not reduce carbon double bond carbon. Only if carbon double bond carbon is in conjugation with phenyl ring, then it can reduce. Then it can reduce that carbon double bond carbon. So another limitation is that when we treat 1 degree alkyl halide, 2 degree alkyl halide with LaH, means lithium aluminum hydride, then obviously they will convert into alkane. But when we are treating 3-degree alkyl halide, when we are treating 3-degree alkyl halide with aluminium, lithium aluminum hydride, then elimination reaction will occurs because we know the 3-degree or tertiary substrates are more prone towards elimination. So hydride ion will act as a base and elimination reaction will occur and our major product will be alkene. So these are the most important points we have to remember when lithium aluminum hydride is given in the question. So let's discuss which functional group is reduced in which functional group when we are using lithium aluminum hydride. For example, if we are using aldehyde, so lithium aluminum hydride basically reduce this aldehyde into 1 degree alcohol. 1 degree alcohol. If we are using ketone, then ketone in the presence of lithium aluminum hydride gets converted into 2 degree alcohol. 2 degree alcohol. Then if we are using carboxylic acid, we are using carboxylic acid. So lithium aluminum hydride reduce carboxylic acid also into alcohol. If we are using ester, so ester in the presence of lithium aluminum hydride obviously gets converted into alcohol. So like RC double bond OOR dash, if we are using as ester, so our product will be RC double RCH2OH plus R dash OH. It will break the single bond of carbon and oxygen between. If we are using alkyl halide, as we discussed earlier, if it is 1 degree or 2 degree, then this alkyl halide will get converted into alkane. But if we are using alkyl halide that is 3 degree, then there is the formation of alkene having the same number of carbon as present in alkyl halide. Another functional group which can be reduced by lithium aluminum hydride, these are the amides like RCONH2. Amide can also reduce by lithium aluminum hydride into amine, RCH2NH2. In these all reactions, we have to concentrate that number of carbon should be same as in reactant. We should not decrease or increase the number of carbon. Second one is that if we are using RCOCl, acid halide, in the presence of LaH, lithium aluminum hydride gets converted into alcohol having same number of carbon as in acid halide. If we are using cyanide, it gets converted or it reduce in amines, RCH2NH2 means 1 degree amine. If we are using isocyanide in the presence of lithium aluminum hydride, again it will reduce and produce RNHCS3 means 2 degree amine. If we are using nitroalkanes NO2, it also reduce NO2 group into NH2 group means we will get amine. So, but if we are using alcohol, so LaH will not reduce the alcoholic functional group. It will not reduce alcoholic functional group. So we can say lithium aluminum hydride, when we are taking in ether, it is a very good hydride ion donor. it reduces almost all functional group. But there are some points which we have to remember. That first point is that lithium aluminum hydride does not reduce double bond until the double bond is present with conjugation with benzene ring, if or phenyl ring. If double bond is in conjugation with phenyl ring, then lithium aluminum hydride reduce it. And another one is that alkyne. If we are using alkyne, then lithium aluminum hydride convert it into alkene, RC. It will convert into alkene if we are treating it with the LH. But double bond will not reduce by lithium aluminum hydride except when double bond is present in conjugation with phenyl ring. The another important point which we have to remember about lithium aluminum hydride is that when we are reducing alkyl halide using lithium aluminum hydride reduce our 1 degree, 2 degree alkyl halide into alkane. But when we are using 3 degree alkyl halide, because 3 degree substrate are more prone toward that is elimination reaction, that's why. And aluminum lithium hydride is a hydride donor, so its hydride ion H minus ion will act as a base, and our 3 degree alkyl halide will convert into alkene. So these are the important point about lithium aluminum hydride. But yes, lithium aluminum hydride is a we can say very strong reducing agent. Second one is NaBH4, sodium borohydride. Yes, sodium borohydride is also hydride donor, but it is we can say mild reducing agent if we compare it with sodium with the aluminum hydride. Why? What is the reason behind it? Let's see. When we discuss lithium aluminum hydride, in the case of lithium aluminum hydride, H atom are attached to aluminium. Hydride ion are attached to aluminium. But when we are talking about sodium borohydride or NaBH4, that these hydride ion or H are attached to boron atom. And the size of boron and aluminium, if we compare, the size of boron is very small compared to aluminium. That's why the size is very small, so this bond is very strong if we compare it with bond between aluminium and H. So if this bond will be strong, so it does not easily donate its hydride ion to every functional group. So yes, we can use this sodium borohydride as a selective reducing agent. So we can say first, sodium borohydride, it does not affect every functional group. So first of all, we have to remember it affect which functional group. First, aldehyde. Yes, it work on aldehyde, and aldehyde gets converted into 1 degree alcohol. Gets converted into 1 degree alcohol in the presence of sodium borohydride. If we are treating it with ketone, ketone can also be reduced using NaBH4. They reduced in 2 degree alcohol. 2 degree alcohol. You can say aldehyde and ketones are more prone toward reduction. So almost these all reducing agent can reduce aldehydes and ketones in 1 degree or 2 degree alcohol. Next one is COCl, acid halide. Yes, or RCOX. Acid halide can also reduce into alcoholic group when we treat it with sodium borohydride, as well as If we are using RX, alkyl halide, they can also reduce RH, alkyl halide into alkane. But we have to remember when we are using sodium borohydride, then sodium borohydride cannot reduce 1 degree alkyl halide. They can only reduce 2 degree alkyl halide as well as 3 degree alkyl halide. So sodium borohydride does not reduce 1 degree alkyl halide. They will reduce 2 degree or 3 degree alkyl halide into alkane. Then sodium borohydride can also reduce sodium borohydride. We can say it also reduce azide. If we have azide, then azide can convert into RNH2 means amine after reduction when we are using sodium borohydride. NaBH4 does not reduce ester, carboxylic acid, etc. Okay. So next is H2Ni and PTPD. We can use nickel, platinum, palladium. Okay, hydrogen over nickel, platinum, palladium we can use. But it is not a selective reducing agent. It is not a selective reducing agent. Just it also reduce almost all functional group, just exceptionally carboxylic acid group. Yes. CWH group does not reduce by this. H2PTPD we cannot use on carboxylic acid. COOH it cannot reduce. It can reduce double bond, triple bond into single bond. For example, if we are using double bond or if we are using triple bond, double bond, then double bond will get converted into single bond. If we are using H2Ni, or we can say we can take platinum, palladium in place of nickel. Triple bond, yes, triple bond also get reduced into single bond when we are using hydrogen nickel catalyst. Another is that if we are using aldehyde, we are using ketone. Yes, aldehyde gets converted into 1 degree alcohol, 1 degree OH. Ketone reduced in 2 degree alcohol, 2 degree alcohol, as well as carboxylic acid, ester, amide, these all can reduce as like lithium aluminum hydride. For example, if we are using RCWH, yes, no, carboxylic acid does not reduce. Yes, we have to remember that CWH group does not reduce by H2Ni. Other like ester, anhydride, if we are using ester, then we will get RCH2OH plus R-OH. If we are using anhydride, so anhydride also can be reduced RCH2OH plus RCH2OH. If we are using amide, amide can also reduced into amine using this H2Ni. If we are using alkyl halide, yes, alkyl halide can also reduce into alkane. If we are using any other functional group, for example RCN, cyanide, it can also reduce cyanide into amine, RCH2, NH2. Similarly, isocyanide can reduce into RNHCS3 means that is in 2 degree amine. Nitro group RNO2, yes, RNO2 also can reduce into 1 degree amine. Azide, yes, azide can also reduce amine. So we can say almost all functional group can be reduced by hydrogen nickel except one, that one is carboxylic acid. It will not reduce by H2Ni. So it is not a selective reducing agent. Next one is that metal plus acid. Okay, if we are talking metal plus acid, so we can take like metal zinc plus acid HCl, zinc plus H2SO4, tin plus HCl, or we can say Fe plus HCl. These metal plus acids we can use as a reducing agent, and these metals are a good, the metals donate their electrons, and through their mechanism they can reduce some functional group. Which functional group metal plus acid can reduce? Which functional group we have to remember? So basically we can say metal plus acid can reduce some specific functional group like RNO2, nitroalkane. Nitroalkane gets converted into RNH2, means 1 degree amine. Then cyanide RCN gets converted into RCH2NH2, means 1 degree amine. Then RNC isocyanide gets converted into 2 degree amine, RNHCS3. So these functional group can convert using these metal plus acids, these type of reducing agents. The last one we are using, not last one, that is the second last, alkali metal plus alcohol. Alkali metal plus alcohol. Alkali metal plus alcohol can also selectively reduce some functional group, not every functional group. So they are also very important. Actually, the reducing agent which are selective reducing agent, they are more important for us, very important for us, because they selectively reduce some functional group. So alkali metal plus alcohol, we are talking about alkali metal plus alcohol, then they can reduce ester. Obviously, ester will reduce into alcohol, RCH2OH plus R-OH. They can also reduce nitro compounds like in RNH2. They can also reduce cyanide into 1 degree amine, RCH2NH2. They can also reduce isocyanide into 2 degree amine. We can also reduce isocyanide into 2 degree amine. Yes, that is our product. And next is our red phosphorus plus HI. Red phosphorus plus HI is also very good reducing agent, very important reducing agent. Why? Let's see. Red phosphorus plus HI. It is also very important. Why it's important? Because when we are talking red phosphorus plus HI reducing agent, it reduce almost all functional group into alkane. Means every functional group it want to convert into alkane. You can observe. For example, if we are starting from aldehydes, aldehydes get converted into alkane. We have to focus that number of carbon are same, r plus 1 carbon, r plus 1 carbon. If we are using ketone, so again we will get alkane. Number of carbon should be same, 2r plus 1c, so 2r plus 1c, number of carbon should be same. If we are using alcohol, it is very important. If we are using alcohol, then alcohol are not reduced by the all reducing agent we have discussed earlier, like H2Ni and whatever LDH, NaBH4. Alcohols can be reduced by red phosphorus plus HI in alkane. red phosphorus plus Hi with alkane. So it is very important. Then next one is that if we are using ester, then it also convert ester into alkane. So we can say it almost all functional group gets converted into alkane and we are using red phosphorus plus Hi. Now there are some other reducing agent which we have discussed in our some previous or earlier videos, that is Clemenson reduction as well as Wolff-Kishner reduction. So they are selective reduction, they are very important. Selective reduction, when we are using Clemenson reduction, then we have to use zinc amalgam in the presence of HCl, and it selectively reduce only and only carbonyl group into CH2 group. When we are using Clemenson reduction selectively reduce carbonyl group into CH2 group, means it form alkane. And second one is Wolff-Kishner reduction. Wolff-Kishner reduction. If we are talking about Wolff-Kishner reduction, then reagent are different but product is the same. So we have to use hydrazine NH2 in ethylene glycol. Then we have to use base KOH. Then carbonyl group gets converted into CH2 group. So Wolff-Kishner reduction as well as Clemenson reduction, that are very important reduction. They are selectively reduce carbonyl group into CH2 group. There is another reducing agent that is also important, that is Dibel, which is also used in organic chemistry. Dibel means diisobutyl aluminium hydride. It is also a hydride donor, but because two isobutyl group create a steric hindrance, that's why it acts as a selective reducing agent. It's not a strong reducing agent. It converts cyanide, carboxylic acid and ester in aldehyde group having same number of carbons. So dibel means diisobutyl aluminium hydride is a good hydride donor, and it is also used as a selective reducing agent to convert cyanide, carboxylic acid and ester into aldehyde group. So it is also a very important reducing agent. So in this class we have discussed all reducing agents. You have to remember the all reducing agents selectivity, which reducing agent work on which functional group, which reducing agent does not work on which functional group, and which functional group can convert into which functional group by using a particular reducing agent. Thank you.